This is Sivakumar. 11th Standard Business Mathematics and Statistics, Chapter number 1, continuation of exercise 1.2. Now problem number 9. You are given two matrices capital A and B. Then you are asked to verify that AB the whole inverse, that is equal to B inverse into A inverse. Here is problem number 9. To verify this result, first we can find AB, A into B, A matrix into B matrix, A matrix, that is 3, 7, 2, 5, B matrix 6, 8, 7, 9. So row by column multiplication. Equals. In the first matrix we have 2 rows, in the second matrix we have 2 columns. So the resultant matrix of order 2 rows, 2 columns. Okay. So you draw like this. After that, first row elements are 3 and 7, 3 and 7. Here also 3 and 7. Second row elements 2 and 5, write 2, 5. Here also 2, 5. And second matrix, first column elements 6, 7. Here also 6, 7. And second row element, second column elements 8, 9 and 8, 9. After that, you have to multiply in this order, first with the first, second with the second, first with the first, second with the second, first, second, first, second. Okay. So we can multiply. 3 6 are 18, 7 7s are 49, so plus 49. Next, 3 8s are 24, and 7 9s are 63, so plus 63. 2 6 are 12, 5 7s are 35, and 2 8s are 16, and 5 9s are 45. That is equal to, if you add together 9 plus 8, 17, balance 1, 5 plus 1, 6, 67. If you add together, we'll be getting 87. Here 47. And finally here 50, 61. AB is over. Now I am going to find out that AB inverse. For that you have to write the formula. AB inverse, that is equal to 1 by determinant of AB into adjoint of AB. The condition is the determinant of AB, which is in the denominator, is not equal to 0. So we find the determinant of AB first, that is equal to AB matrix. Here it is, right, 67, 87, 47 and 61 equals 67 and 61. You have to multiply. If you multiply, you'll be getting 4087, and then you have to multiply these two, 47 and 87, you'll be getting 4089. Then you have to write minus 4089. So 4087 minus 4089, that is equal to minus 2. Yes, which is not equal to 0. Therefore, you can write AB whole inverse exists. Yes. Then you have to find out adjoint of AB. Okay. Therefore, adjoint of AB equals, in the AB matrix, you have to interchange the leading diagonal elements. Here is AB. Leading diagonal element 67 and 61 becomes 61 and 67, 61 and 67. For the non-leading diagonal element, change the sign only. 87 and 47 becomes minus 87, minus 47. Minus 87, minus 47. So adjoint of AB is over. Therefore, we can find that AB the whole inverse. AB the whole inverse formula, 1 by determinant of AB. Yes. Determinant of AB is minus 2, already we got it, here it is, minus 2, right, minus 2 into adjoint of AB, here it is 61, minus 87, minus 47 and 67. So you can retain that half only outside the matrix. So which one is left out? Minus. So multiplied by minus, you'll be getting minus into 61 is minus 61, minus into minus 87 is plus 87, minus into minus is plus 47, minus into 67 is minus 67. So LHS over, let it be number 1. Now I go for RHS. This is LHS, you can put LHS over here. In RHS, we have to find out B inverse, after that A inverse, finally B inverse into A inverse. So RHS, B inverse, write the formula, B inverse that is equal to 1 by determinant of B into adjoint of B. Condition determinant of B is not equal to 0. So we can find the determinant of B first. Determinant of B matrix, here it is 6, 8, 7, 9. 6, 8, 7, 9. Okay. Write the elements inside the two vertical lines that represents determinant. Now you can expand the determinant. You know how to expand, multiply these two. 6 9s are 73, 40, 54, and 7 8s are 56, becomes minus 56. Together minus 2, which is not equal to 0. Therefore, B inverse exists. Then you can find adjoint of B. Adjoint of B equals, for the B matrix, interchange the leading diagonal elements. 6 and 9 becomes 9 and 6. 9 and 6. Then for the non-leading diagonal element, change the sign only. Plus 8 and plus 7 becomes minus 8 and minus 7. Therefore, you can find B inverse. B inverse formula, here it is 1 by determinant of B. 1 by determinant of B, that is minus 2 into adjoint of B. Adjoint of B, here it is 9 minus 8 minus 7, 6. That is equal to, I retained 1 by 2 only, multiply by minus, minus into 9, minus 9, minus into minus 8 is plus 8, minus into minus 7 is plus 7, minus into 6 is minus 6. B inverse over. Then you have to find out A inverse, so write the formula for A inverse. A inverse, that is equal to 1 by determinant of A into adjoint of A. The condition determinant of A is not equal to 0. So I am going to find out determinant of A first. Therefore, determinant of A, that is equal to A matrix, here it is 3, 7, 2, 5. 3, 7, 2, 5. That is equal to, have to multiply the leading diagonal element. 3 5s are 15, right, as it is. Then 2 7s are 14, becomes minus 14. So 15 minus 14, that is 1, which is not equal to 0. So you can write A inverse exists. Okay. Then you have to find out that adjoint of A. You know how to find the adjoint of the matrix. Here is the matrix A. 3 and 5, we have to interchange 5 and 3. And 7 and 2 becomes minus 7 and minus 2. Minus 7 and minus 2. Therefore, A inverse, that is equal to 1 by determinant of A. Determinant of A is 1 into adjoint of A, that is 5 minus 7 minus 2, 3. That is equal to 1 by 1 is 1. 1 into anything is same thing. So you write 5 minus 7 minus 2, 3. So finally you have to find out the B inverse into A inverse. B inverse into A inverse, that is equal to, so already we got that B inverse. Here it is, B inverse, that is equal to 1 by 2 minus 9, 8, 7 minus 6. 1 by 2 minus 9, 8, 7 minus 6. into A inverse. Here it is, that is 5 minus 7 minus 2 3. Okay children, you have to retain that 1 by 2 as it is. Then you can go for that row by column multiplication, row by column. Okay, here we have 2 rows in the first matrix, here we have 2 columns in the second matrix. So the resultant matrix of order 2 rows 2 columns. So you put like this, it will be easy for you to do the multiplication. Okay, see that the first matrix, first row elements minus 9 and 8, here also have to write minus 9 and 8. The second row 7 minus 6, here also 7 minus 6, and first column 5 minus 2, here also 5 minus 2, and second column minus 7 3 minus 7 3. That is equal to, write half as it is into, you have to multiply in this order, you know very well, first with the first, second with the second, like that, first first, second second, first first, second second. You have to multiply these two, minus in 9 into 5, that is a minus 45, and 8 into minus 2, that is minus 16. Then minus 9 into minus 7 is plus 63, and 8 3s are 24. Then you have to multiply these two, 7 5s are 35, and minus into minus plus, this is minus 2. Okay, minus into minus plus 6 into 2, that is 12. Then 7 into minus 7 is minus 49, and minus 6 into 3 is minus 18. Children, you have to add minus 45 minus 16, that is equal to minus 61. 63 plus 24, that is equal to 87, and together this is 35 plus 12, 47. Finally add together, will be getting minus 67. So let it be equation number 2. Now we have to verify that LHS and RHS are equal. Look at that, 1 by 2 minus 61, 87, 47, and minus 67. Even that equation number 1, here it is, that is LHS result. Same 1 by 2 minus 61, 87, 47, and minus 67. So finally you can write the result. It is verified that from 1 and 2 LHS and RHS are equal. You write the result over here. Therefore it is verified that from 1 and 2, it is verified that AB the whole inverse, that is equal to B inverse into A inverse. So problem number 9 is completed. Now I'll be teaching problem number 10. Problem number 10. That is problem number 10. Find lambda if the given matrix has no inverse. I consider the given matrix as capital A. So I consider the given matrix as A. You are asked to find out the value of lambda. This is a condition. The matrix A has no inverse. Already we have seen in that previous problem also. Look at that. If A inverse exists, means the condition determinant of A is not equal to 0. Here no inverse means determinant of A is equal to 0. So write the result here. Since A, the matrix A has no inverse, determinant of A is equal to 0. This is a condition. Now we write the determinant. That is equal to 0. Here 1 1 3, first row, second row 2 lambda 4, and the third row is 9 7 11. You know how to expand the determinant. Usual expansion. At the top of the first row you put plus minus plus, then write 1 into, then minus into 1 minus 1 into finally plus 3 into that is equal to 0. See, the element 1, it presents in the first column and first row. Leave off these two, you'll be getting these 4 elements. You can straightaway write 11 into lambda, that is 11 lambda, and 7 fours are 28 becomes minus 28. Like that, leave up the second column and first row. These 4 elements will be there. You have to multiply these two. 2 into 11, that is equal to 22, and 9 fours are 36 becomes minus 36. Finally, you can leave up the last column and the first row. These 4 elements left out, you have to multiply these two. 2 sevens are 14, right, as it is, and 9 into 11, 9 into lambda is minus 9 lambda. Actually, we are getting plus 9 lambda, but you have to write minus 9 lambda, right? Then usual multiplication for finding the value of lambda, simply here 1 into anything is same thing, so write 11 lambda minus 28, right, as it is, minus 1 into 22, that is minus 22, minus into minus plus 1 into 36 is 36, and plus 3 into 14, that is equal to 42, plus into minus minus 3 into 9 lambda is 27 lambda, that is equal to 0. Here 11 lambda, here 27 lambda, together 11 minus 27, that is equal to minus 16 lambda. Yes, then you can add the constants, and all minus 28 minus 22 together minus 50. Minus 50, 36 plus 42, that is equal to 78, that is equal to 0. Yes. Now minus 16 lambda, 78 minus 15, that is equal to 28, plus 28 is equal to 0. So lambda we have to find out, so minus 16 lambda, that is equal to plus 28 comes right hand side, minus 28. Both the minus get cancelled, so lambda that is equal to 28 divided by 16. You can go for 4 table. If you divide by 4 table, here 4 times, here 7 times. 4 sevens are 28, 4 fours are 16. So the value of the lambda is 7 by 4, which implies lambda that is equal to 7 by 4. Yes, problem number 10 also completed. Then I'll be teaching the last problem, that is problem number 11. Problem number 11. Problem number 11. You are given two matrices X and Y. You are asked to find out that values of P and Q. The condition is the matrix Y that is equal to inverse of the matrix X. Y that is equal to X inverse. You are given two matrices. This is the condition given. I consider the condition as number 1, equation number 1. So we can find the X inverse first. We know that X inverse that is equal to 1 by determinant of X into adjoint of X. Condition is determinant of X is not equal to 0 because the determinant of X is in denominator. So we can find the determinant of X. Therefore, determinant of X equals X matrix, that is 8 minus 1 minus 3, 8 minus 1 minus 3, minus 5, 1, 2, 10, minus 1, minus 4. This is matrix X. Now I am going to expand the matrix. Usual expansion, you know how to expand that, determinant, not matrix. Plus minus plus at the top of the first row, that is equal to, first write 8 into, then minus into minus 1, that is plus 1 into, finally plus into minus 3 is minus 3 into. Then leave the first column and first row. These 4 elements are there. You can directly multiply. 1 into minus 4 is minus 4, right, as it is. And minus 1 into 2, minus 2, but you have to write plus 2. Yes. Next one, you can leave the second column and first row. You have to multiply these two, minus 5 and minus 4 together is 20. And 10 into 2, that is 20, but you have to write minus 20. Finally, leave the last column and first row. We have these 4 elements. Multiply these two, minus 5 and minus 1 will be getting plus 5, and 10 into 1 becomes minus 10. That is equal to 8 into, together, minus 4 plus 2, that is equal to minus 2, plus 1 into 20 minus 20, that is 0, minus 3 into 5 minus 10, that is equal to minus 5, equals 8 into minus 2 minus 16, then 1 into 0, that is 0, minus into minus plus 3 5s are 15, together minus 16 plus 15, that is equal to minus 1, yes, which is not equal to 0, so you can write x inverse exists. Yes, then you have to find out the adjoint of x. Write the formula first. Adjoint of x, that is equal to, you know very well, cofactor matrix of x, that is xij, and its transpose. Yes, we can find that adjoint of the matrix x, that is equal to, in rough word column you write the given matrix. X matrix is 8 minus 1 minus 3, 8 minus 1 minus 3, minus 5 1 2, 10 minus 1 minus 4. Then you have to write the first column and second column again. First column, that is 8 minus 5 10, and second column is minus 1 1 minus 1. And write the first row again, 8 minus 1 minus 3, 8 minus 1, and the second row also again you have to write minus 5 1 2 minus 5 1. After that you have to strike out that first column and first row. First column and first row to be striked out. Yes, after that we have to put like this. Each and everyone should be considered as a 2 by 2 minor. Then we can start multiplying. If you multiply these two, you will be getting 1 into minus 4, that is minus 4, right, as it is. Then minus 1 into 2 minus 2 becomes plus 2. Then 2 into 10, that is 20, right, as it is. Minus 4 into minus 5 is plus 20, you have to write minus 20. Then minus 5 into minus 1 is plus 5, right, as it is. Then 10 ones are 10, becomes minus 10. Then consider this, if you have to multiply these two, minus 1 into minus 3 is plus 3, right, as it is. If you multiply these two, you will be getting plus 4, but you have to write minus 4. Then minus 4 into 8 is minus 32, and minus 3 into 10 is minus 30, but you have to write plus 30. Like that, 10 into minus 1 is minus 10, right, as it is. Then if you multiply these two, you will be getting minus 8, but you have to write plus 8. Finally, if you multiply these two, minus 1 and 2 becomes minus 2, right, as it is. 1 into minus 3 is minus 3, but you have to write plus 3. Minus 3 into minus 5, that is plus 15, right, as it is. If you multiply, you will be getting 16, but you have to write minus 16. So at the last, you have to multiply these two. 8 ones are 8. Then minus 5 into minus 1 is plus 5. You have to write minus 5. At that top, you have to put the transpose, that is equal to minus 4 plus 2, that is minus 2. 20 minus 20 is 0. 5 minus 10 is minus 5. 3 minus 4 is minus 1. Minus 32 plus 30 is minus 2. Minus 10 plus 8 is minus 2. Minus 2 plus 3 is 1. 15 minus 16 is minus 1. 8 minus 5 is 3. And it transpose. That is equal to, for transpose, you know very well, interchanging the rows and columns, right? The first row in first column, minus 2, 0, minus 5. Second row in second column, that is minus 1, minus 2, minus 2. And the third row in third column, 1, minus 1, 3. Over. Adjoint of A is, adjoint of X is over. Finally, you can write that X inverse. X inverse, the formula already I have written, that is 1 by determinant of X. Determinant of X we have, that is minus 1, right, minus 1, into adjoint of X, here it is, write this one, minus 2, minus 1, 1, and 0, minus 2, minus 1, minus 5, minus 2, 3. Then you know very well, 1 by minus 1 is minus 1, so multiplied by minus 1, minus 1 into. So you have to change the sign only. Minus 1 into minus 2 is plus 2, minus 1 into minus 1 is plus 1, minus 1 into 1 is minus 1, like that. Here 0, this becomes plus 2, this becomes plus 1. Then if you multiply by minus, it becomes plus 5, plus 2, finally minus into 3 is minus 3. I got that x inverse. Now equation number 1 implies, equation number 1, what is here? Y that is equal to x inverse. Y matrix here it is 2, 1 minus 1, 2, 1 minus 1. Second row 0, 2, 1, 5pq. Third row 0, 2, 1, 5pq. That is equal to y equal to x inverse given, x inverse here it is. This is x inverse. X inverse, that is 2, 1 minus 1, 0, 2, 1, 5, 2 minus 3. Look at that. Here we have 3 rows 3 columns matrix. Order of the matrix in the left hand side is 3 rows 3 columns. Even in the right hand side the order is 3 rows 3 columns. 3 rows 3 columns. So in between the two matrices we have the equal sign. What it means? The two matrices are equal. Equal matrices means same order. Same order means the corresponding elements are same. Look at that. Here 2, 1 minus 1. Here also 2, 1 minus 1. Second row 0, 2, 1. Here also 0, 2, 1. Even in third row, here 5, here also 5. So you are asked to find out the values of p and q. Look at that, p that is equal to 2 and q that is equal to minus 3. P that is equal to 2 and q that is equal to minus 3. You write the result at last. Therefore, p that is equal to 2 and q that is equal to minus 3. Children, problem number 11 also completed. So exercise 1.2 is over. The next video I will be teaching that exercise 1.3. Thank you, children.